So we were discussing about the air compressor. So basically we are discussing what is compressor, what are the use of air compressor, what is the use of compressed air, what are the classification of air compressor, and then we will discuss what are the parts of air compressor. Now we will discuss what is reciprocating air compressor and what is the principle of operation of reciprocating air compressor. So what is reciprocating air compressor? Reciprocating air compressor is a machine which takes air or gas during the suction stroke at low pressure and then compress it to high pressure where in the piston cylinder arrangement. So it is known as a reciprocating compressor. So basically you should remember that reciprocating means your piston cylinder arrangement must be there so that we can say that it is reciprocating compressor. Okay. So what is the principal operation? So to compress the air or to run the compressor or to compress the air, some external work must be supplied to the compressor. From where? From the prime mover. Prime mover may be, I think, maybe some engine, maybe some, that is a motor also. So what happens? So the part of the work that will be supplied to the compressor, the part of work will be lost. How the part of work will be lost or where it will be lost? The part of the work will be lost to overcome the frictional resistance between what? Between the piston surface and the cylinder. And some cylinder of the compressed air or air compressor is cooled. Why the cooling of the compressor is required? Because it will cooling of compressor will minimize the work input. How? How the cooling of air compressor will minimize the work input? So we know that the air is a gas, you can say ideal gas. So the characteristic of a gas is to expand. So if we are giving it will be at high temperature. So it wants to expand. So when it will want to expand, you want to what? You want to compress. It wants to expand its volume, but you want to compress its volume. Then at that condition, you have to give the more work input. For that reason, though it is a work absorbing device, so minimum work will be required so that efficiency will be more. So for that reason only, we have to do what? We have to cool the compressor. Okay. Then that air compressor, that air will be compressed by a reciprocating compressor. That cannot be used directly to any other application. What will happen? It will be first stored in the air receiver, then it will be go for further application. So that is the principle of what? That is the principle of reciprocating air compressor. Okay, next we will discuss what is the working of. So see here, this is the reciprocating air compressor, this is the piston, this is your suction valve, this is your delivery valve, this is your air filter, this is the piston, inlet port or discharge valve here is there, this is your inlet valve, these are the both what? These are the one directional valve, you know that because of pressure difference it will be open and close. And this is the receiver air storage tank. Okay. So these are the arrangement of what? Air compressor. So next we will discuss what is the working principle of single stage reciprocating air compressor. Okay, we will discuss what is the working principle of single stage reciprocating air compressor. So in the single stage reciprocating air compressor, so see, this is the diagram. Here this is the suction line. This is yellow color one is your suction valve. This is your delivery valve or discharge valve. This is your head suction valve. Then this is your connecting rod, piston. This is your crankshaft. And this here, see the diagram here. So the crankshaft will be connected with the motor. So to run the compressor, first we have to run the motor. And when the motor shaft will be run, the motor shaft will be directly or by chain or by the rope or by the pulley that will be connected with the crankshaft. So from that, the motor shaft will transmit the power to the crankshaft. Okay. And from that, the crankshaft will be rotated and the power will be transmitted to what? Piston through what? Through the connecting rod. The rotary motion will be converted to reciprocating motion by the what? By connecting rod. And now, what will happen? For that, the piston will be moved downward. The piston will be moved from the TDC to BDC. When the piston will be moved downward, what will happen? the negative pressure of vacuum will be created inside the cylinder. There is nothing means there is a vacuum is there. So due to pressure difference, the atmospheric air will be passed through the air filter. Then outside there is atmospheric air, and inside the cylinder there is negative pressure, that is a vacuum is there. So because of pressure difference, the suction valve will be open and the atmospheric air, a filtered atmospheric air will be entered into the compressor or enter into the cylinder. Okay, and this process will be continued when the piston reach at what BDC position, bottom descent. Okay, next what will happen? That is your one stroke. Okay, in the second stroke, what will happen? In the second stroke, the piston will be try to move from BDC to TDC, where you get the input from the motor. The second stroke, what will happen when the piston will be start move from BDC to TDC? Then this suction valve will be closed and the piston will be move upward. When the piston will be move upward, the volume of the compressor, volume of the cylinder will be decreases. And if the volume of the cylinder will be decreases, gradually the pressure will be increases as well as temperature will be increases. When the pressure temperature of inside the cylinder will be more, then this delivery line pressure, due to this pressure difference, the delivery valve will be open and the compressed air inside the cylinder will be passed, will be go to the or will be passed to the storage tank. Okay. These are the two stroke. In the two stroke, this is from TDC to BDC and BDC to TDC. In the two stroke, the suction and compression will be carried. Okay. So this is known as a single acting compressor, where single stage and single acting. Single stage means one cylinder, single acting means in the one side of the piston the air will be compressed. So that is known as your what? Single acting compressor. Okay. This is the working. These are the written here. So next, what will happen? So in what is the working? In the single stage reciprocating air compressor, the entire compression will be carried out in the single stage. The compression is affect in the one end of the piston cylinder, so it is known as what? Single acting. And if the compression is affecting the both end of the piston cylinder, that is known as a double acting. Here the opening and closing of the simple check valve, or that is your valve, will be operated by the what? By the function of the control by the clamp, or you can say due to the pressure difference. The weight of the air in the cylinder will be 0. And when the piston is at top dead center, the position where we are neglecting what? You are neglecting the clearance volume. So when the piston is start moving downward, downward means from TDC to BDC, the pressure inside the cylinder will fall below the atmosphere, and the suction valve and inlet valve will be open. How? Because of pressure difference, and air will be drawn into the cylinder through the filter, and that stroke is known as a suction stroke. And when the piston will be move upward, the compresses the air in the cylinder. Inlet valve will be closed when the pressure reaches the above atmospheric pressure. Then it will be sent to the what? From the discharge valve, it will be sent to the receiver. Okay. So what happened in the double acting cylinder? In the double acting reciprocating air compressor, the suction stroke and a suction stroke is in process at one end and compression at the other end. In the both ends, suction and compression stroke will be there, that is known as your double acting reciprocating air compressor. Then we will discuss the PP diagram of single acting reciprocating compressor without clearance. So if you see the diagram, there is no clearance is there. What is clearance? When the piston is at top dead center, when piston is at top dead center, the gap between or the space between the cylinder head and the piston head is known as your what? Is known as your clearance. So here we are not considering any clearance. Okay. So see, when the air will be, when the piston will move from TDC to BDC, the air will be enter into the cylinder. Which air? Atmospheric air will be enter into the cylinder. So here, if you see, so A to 1, this A to 1 is your what? The atmospheric air means constant pressure. The air will be enter into the cylinder. So A to 1 is your what? That is your suction. Here, this one is your TDC, top dead center. This one is your, you can say, this one is your TDC. You can say this one is your top dead center TDC. Okay. This one is your bottom dead center, that is your BDC. Bottom dead center, that is your BDC. So when the piston move from TDC to BDC, the atmospheric air will be enter into the cylinder. So that is your A to 1, that is your constant pressure suction. Then it will be compressed from 1 to 2, that will be the compressor. Here you can compress the air in the three thermodynamic process. By isothermal you can compress, by polytropical you can compress, or by isentropical you can compress. Okay, so you can compress 1 to 2, there will be the compression, maybe isothermal compression, maybe your polytropic compression, maybe your isentropic compression. Then 2 dash to B or 2 to B or 2 double dash to B. That is your what? That is your delivery. That is your delivery. So when the piston move from TDC to BDC, that volume is known as your V1. So when the piston move from TDC to BDC, that volume is known as your which volume? That volume. So you can say V1 is equal to what? V1 is equal to Vs. Okay. So this is your V2. Here to your V2 dash or V2 or V2 double dash. Here the pressure is your P1. So inlet pressure is your P1 and here delivery pressure is your what? P2. So A to 1 is your suction, 1 to 2 is your compression and 2 to B is your what? 2 to B is your, that is your delivery at constant pressure. So these are the process of what? These are the processes of your single acting reciprocating compressor without clearance. So A to 1 is your suction stroke, here air will be enter, 1 to 2 polytropic compression, 1 to 2 dash isentropic, see 1 to 2 polytropic, 1 to 2 dash isentropic and 1 to 2 double dash, that is your isothermal compression. 2 to B, that is your discharge of compressed air through the delivery valve at a pressure what? P2. And B2A, there is no air in the cylinder and return to the origin. Because why B2A? There is no air because we are not considering the clearance volume. If you are considering the clearance volume, so some of the air may be in the clearance volume and which when the piston move from the BDC to TDC, then it will be expanded. Okay, TDC to BDC, then it will be expanded. So what we will do here, we will basically see how many work input you can give to compress the air, that you have to find out what is the work input to the compressor. Okay, this is what? This is your pressure and volume diagram. This is your pressure and volume diagram of single acting reciprocating compressor without clearance. Okay. Next we will discuss how you can calculate what is the work input to the compressor if we are compressing in polytropically, isothermally or isentropic.